Yes, ma'am. Live start.
Okay. Thank you. I welcome to the second session on online to all the deep learning candidates, participants. So let's take few of the queries first, and later on I will introduce to the new topic of deep learning, right? So let me read out the queries first, and later on I will answer for the query. Okay. So the first query is based on the exam, the end-term examination that is going to be held. So here, what will be the type of questions in the exam? Will it be assignment-based or programming-based? See, the deep learning course part 1 is based on the theoretical concepts, and as well as you have already gone through so many weeks of course content, right? So nowhere programming part is there, right? So it is based on the theoretical concepts. So what you can do is you go through the course content, the full course content, and definitely the questions would be from the videos that have been shared with you all, right? So the second question here is, during this course, we did not get any practical assignments or tutorials. Why so? Just reading theory is resulting in vague understanding of the concept. See, here, to understand such a advanced course, one must have the strong theoretical concept. Okay, that means background of theoretical concepts is required to understand, to make the clear understanding of the concepts, right? So I know as this particular course is framed based on theoretical concepts in order to gain the knowledge. Once you get the knowledge in the given course, okay, given concept, right? So what you can do is you can build up the programming or implementation part later on. So here the motive behind developing this particular course is to give you theoretical concepts first, and later on you may develop the practical exposure, that is implementation part by yourself, right? Hence, programming exercise and definitely tutorials are not provided with respect to the course. Okay. The next question again is based on the exam part. I have registered for exam in deep learning course. I would like to request you to kindly provide the detailed solutions for the assignments in deep learning course, right? It is difficult to understand numerical problems without detailed solutions for the advanced course. Also, the students' knowledge and understanding will enhance if detailed solutions to be provided. Kindly look into the matter and please do the needful. Okay, the answer for this particular query is, as I have already replied for the previous query, right? The concepts must be clear to you, definitely with respect to each of the module that has been shared week-wise, right? Once you are thorough in understanding the concept, then I don't think it is much tough to solve the assignment questions, right? So the best way is to, you all might have tried all the assignment questions by yourself, and you have even submitted the assignments on time, right? So my suggestion is better if in case you are not able to solve any of the or some of the questions or few of the assignment questions, so better you may post in a question answer forum. Before even posting, first search for that particular assignment question which might be posted by someone else. Okay, so if you are not able to find the query related with the assignment question that you are facing, so what you can do is you may post the query in the portal. So we are definitely we are going to help you out, and we will provide you the step-wise solution. But first you try by yourself, and once you are not able to find the solution, then you may post it, right? Okay, right. So the next query is, if I have extracted some of the handcrafted features from the input signal, then what will be the structure of the GL model? Okay, so here you might have extracted some of the features, right? So hand-coded features you might have extracted. So what you can do is only change that it will happen with respect to deep learning architecture. Okay, the model in which particular layer the change would occur. Basically it would occur at the input layer itself, right? As you might have changed, or you might have extracted few of the features out of the given set of features. Okay, that means from the input itself you have extracted handful of features. So now those handful of features will be fed into the model, right? So number of neurons would be equal to the number of features that you might have extracted. So the change here is at the uh, input layer itself, and rest of the architecture would remain same. For example, you might have it, like build the model based on some input layer, some hidden layers and output layer, right? So here in this case only you have changed the input layer by extracting some of the features. So those features would be fed as an input to the model, right? So input to the model here is nothing but those features will be passed to the number of neurons that you are creating at the input layer. Rest of the layers like hidden layers and output layers would remain the same, because your main motivation behind getting the solution, that is the output layer, will also not be changed, right? Only change is with respect to the input layer. Okay, the next question here is, during the course instructor often mentioned regarding ML course, is the said ML course available in the video format? If yes, is it possible to share the content of it? Okay, if no, can you please guide us a systematic way to learn the classical ML from the basic to the advanced level? Okay, so and in fact the best possible resource, etc. Okay, the answer to this query is there is no ML course with respect to this particular course, right? So what you can do is you can go through the different sort of ML courses which are available in the Neptel platform itself. So better you go through, first you scan through the different ML courses which are already available. So after that, after scanning, what you can do is you can choose the suitable one, the most suitable one, right? So someone might be interested in some of the part, for example, supervised learning algorithms, right? So better you see the suitable kind of course, right? And you can enroll in that particular course to get the deeper understanding. And even in fact, you can explore, there are various ML as well as advanced ML courses which are available in the Neptel platform, right? So with this, we do have some more queries with respect to the course content. So here I will be sharing my screen. to further right. So here the question is, how can we say the overall size of the final output gets shrink to the fraction of its input? Give an example which takes input size, filter size, and stride with no padding. Correct. So the query here is how it would reduce the fraction of the how it would reduce the input, how it would reduce the output size, right, by the fraction of some amount of the input. So what you can do is, let us consider the input. The input size here is, let's take 7 cross 7, and let's try to apply one filter on this particular input. The size of the filter here is 3 cross 3, that is spatial extent is 3, right? So when we apply this particular filter over this particular given input image, we all know when we consider stride rate as 1 and padding here is no padding, so let's assume the padding value as 0. So when we do this, then we can be able to compute the output, right? Output from this particular input, right? So what we will do is, we do take the filter and we do convolve it over the entire image from left to right and top to bottom, right? So once we do that, for each wherever we are applying this particular filter, we do start applying from the leftmost part of the input image, that is 7 cross 7. Once we do that, we will be convolving the filter over that part of the image, and it will produce me some output. Okay, so that would be part of my output image. Again, I will move the stride rate here. I have taken as 1, so I will be moving my filter by 1 position. Okay, so it will, like this, it will go from convolving the filter from on the input image from left to right and top to bottom. For example, if I take this particular input image and this particular filter, and when I convolve it over this initially or this left to topmost left side, once we convolve it, it would generate one output that is over here. That output would be part of this particular output layer. Okay, once we convolve it over this particular part subregion, then I will move the stride to 1 position. Now, instead of convolving over this particular 3 cross 3, now it will move the filter and it will convolve over this particular region. Again, it will compute the convolution, and again it will produce some output, and the result I will be taking into my output layer. Okay, like this particular filter will be moved from left to right. Once we reach the last position, when we get this particular output, though, so next would be, we will be striding to the bottom side, right? So like this, I will go over the entire image, right, from top to bottom. So now, whenever we are convolving, the input image, size of the input image was 7 cross 7, and size of the filter was 3 cross 3. So based on the formula that we have discussed in the theory part, so whenever we convolve this particular filter over this, so it is 7, here it is 7 cross 7, here it is 3 cross 3. So you will use the formula that is the width of the input image minus width of this particular filter plus 1 divided by stride rate, that is S over here, plus again the 1. So when you do that, you will be getting 5 cross 5 as your output image, right? Here padding P is equals to 0. That is there. Otherwise, we could have got, we could have applied instead of P equals to 0. If I take P equals to 1, then my result would be different, right? So when my result would be different, now you can see my because we have applied this particular filter on the input, and it resulted in 5x5 output image. Okay, so it has reduced the input size from 7x7 to 5x5. Instead of this, if we apply padding, if I don't want to reduce the size of this particular output image, okay, or I don't want to get the reduced size as in the form of output image. So what we can do is we can plan the padding. Okay, we can pad to this particular some of the values, pixel values to this particular input image, so that the resultant output that it is going to generate will be same as my input image, right? So why this particular shrinking is occurring, why this particular output it is reducing to 5x5, why it has not retained to 7x7? Because you all know that we have applied this particular filter on this particular sub-region. When we apply on this particular first sub-region, okay, so here the case may be whenever we are applying, we might be computing, we might be looking for this particular pixel. Okay, that means I'm not performing convolution operation on this particular image, on this particular input pixel. Why we are not applying on this particular input pixel? Because if I try to apply this particular filter for considering this particular input pixel, then some of the rows and some of the columns, the values we may not get. Okay, so to compute the average value, when we convolve it, it will generate the problem, right? So for that sake, we always without padding, we always do compute for this particular input image for the given filter size, right, from this particular pixel. And for that sake only, if you don't want to get the reduced input, then padding is the best option, right? So again, whenever we apply the convolution operation, and later on, usually in convolutional neural networks, CNN, you might have seen the entire architecture, right? So many researchers have come up with their own architectures by having these convolutional layer and pooling layer, right? Set of convolutional layer and pooling layer, again next set of convolution and pooling, and so on. Okay, and at the end, maybe based on the architecture, some of the architecture, there you might find two fully connected layers after following a set of convolutional line pooling, convolutional line pooling, and so on. So at the output, you will be getting the single vectored output would be generated, right? So this is with respect to convolutional neural network architecture, where you will be finding, or you will be able to see in most of the existing architecture also, like AlexNet, ZFNet, ResNet. Okay, in most of the architecture, you will find these convolutional layer and pooling layer, which are used mostly in the initial part of the architecture, right? So when we take this 4x4 as an input image, okay, so whenever we try to find the max pool on this particular input image, okay, so first we will need to check the size. Here, size of the max pool that we are considering is, take the 2x2 matrix. Okay, from the 2x2 matrix, stride value as 2. Okay, so take the max pool over this particular 2x2, compute the maximum value. Here maximum value will result as 7 among these two cross 2, that is among these 4 pixels, the maximum value is 7. So take that particular, so that particular value will be carried forward for the next layer, correct? Similarly, as stride rate is 2, so here instead of moving on this particular part of the input image, we will be computing the max pull on this particular part of the input, right? Because stride rate here is, we have considered it as 2, right? So whenever we take stride rate as 2, again among these 4, now the maximum value would be moved forward like this. 9 would be carried forward. Next is as we have reached end of the input from left to right, right? So what we need to do is we need to move to the bottom side. Okay, so top to from top we start, and from top left to right, and once we reach the right side, we need to move towards the bottommost. Okay, we will be going through the bottom side. So like this, whenever we do scan in case of convolutional operation or in case of max pooling operation, what we do is we do compute the maximum value or convolutions operations from left to right and top to bottoms approach, right? So next value that that is going to be carried forward among these 4 is the maximum value, that is 9 would be moved forward, right? And at the end, these 4 among these 2 cross 2, I will take the maximum value, that is 8. So you can note one thing here, the width and height of the final output. Okay, this is the final output and this is the input for the maximum max pull, right? So width and height of the final output get reduced to be half of their input, right? So here it was 4 cross 4, here it has reduced to 2 cross 2, right? So therefore, the overall size of the final output gets shrink to 1/4 of its input. So here there were total number of pixels, if I consider, there were 16, and here it has reduced to 1/4 of this value, right? Okay, with these queries, let me introduce to the new topic, that is object detection. Okay, so object detection, in this we have already seen the classification part, right? In the classification, given an image, we are able to classify which particular in which particular image that particular image belongs to, in which particular class that image belongs to, right? So suppose I want to classify the given image, input image, into 2 classes, suppose cat and dog. Okay, so whenever we at the test time, whenever we do feed or whenever I do provide the input of which belongs to cat image, then my model should be able to predict or give me the output as this particular image belongs to of cat's category, right? So here there we were doing classification part. Given image, I'm able to predict which particular class that particular image belongs to, right? So now moving ahead, we do have one more problem, that is detection problem. In the detection problem, we do predict, okay, to predict the objects present in a given image along with their location. That means along with we need to answer, or our model would be able to answer the questions, queries in terms of what and where. Okay, so what type of object that the image has, it would answer in terms of classification, as well as it would answer where that particular object lies in the given input image. Okay, so there might be some some sort of images where I wanted to see how many birds are there in the given image. Okay, I just want to count how many numbers of birds in the given image. So now we know that if I take the input image, and that particular input image is of a real-time input image, and we know mostly birds do fly in the sky, right? So your model should be able to give the exact location where those birds are, right? And later on, once you retrieve the birds, you can easily give the count how many birds are present in that particular image, right? So the problem here is we need to provide, apart from the classification, we need to provide where exactly my object of interest is located. Okay, that is the location part. Okay, and considering object detection, we do have many algorithms, right? So one of the most used algorithm is you only look once, that is YOLO. So here in this particular algorithm, we do have there are various versions of this YOLO that exist: YOLO V3, V4, V5, and so on. Slim YOLO. There are multiple variations of this particular algorithm which exist. So let us look at the basic one. Okay. So here, given the input image is divided into n number of grids. Okay. So here I would be having total number of grids would be S cross S. So if the input image is this, then I can divide this particular input image into 3 cross 3. So that total number of grids that would be forming in this from this particular input image are 9. Okay, once you break this particular input image into in terms of grids, then here each grid should produce the result. Correct. So here this particular first, let me call this as first grid, this one as second grid, and this one as third grid, and so on till 9 number of grids. So each grid predicts B number of bounding boxes. So why this particular B number of bounding boxes? Here, whenever the model finds an object, then it should tell us the location, and in terms of bounding box, that means it would draw the one box around this particular object. Correct. So each of the given each of these grids would be able to produce the B number of bounding boxes. Correct. As well as some confidence scores would be generated with respect to each of the bounding box it is generating. Now, the confidence score of the first grid. Okay, the first grid, suppose it has generated 2 bounding boxes. Okay, now the confidence score with respect to those 2 bounding boxes would be 0, because as such no object that exists in this particular grid, right? So bounding box confidence score, suppose second grid also produced the 2 number of bounding box. Now those 2 number of bounding box will also generate the confidence score. Okay, this time it will definitely, the confidence score will not be 0, it will be high, right? Similarly, if you consider this particular grade or this particular grade or any of the other grade, the confidence score would be 0 as compared to the second grade. That means here the grid is responsible for providing the output. Each grid is responsible to for the prediction. Okay, only if the object exists in that particular grid. Okay, object center, to be very specific, object center exists in that particular grid. We can say that yes, confidence score of that particular grid for the given bounding box would be high. Okay, so how do we compute the confidence score if some object exists? So it would be computed with a given formula, that is probability of an object multiplied by intersection or union. Okay, with respect to truth and predicted. That means That means, first of all, suppose we all know that second grade confidence score should be high. Okay, why second grade confidence score is high? Because objects do exist in the second grade, right? And definitely object center exists in this particular grade. For that sake, probability of whether is there any object that exists inside this particular second grade. If it is yes, then we need to provide it as probability as high, right? And we will see how do we compute this particular factor in subsequent slides, right? So as I said, here each of the grid that we have that the of each of that is H and the image, okay, in the given image. Width and height of the object in the with respect to given image, right? Similarly, the confidence. IOU, how do I compute the confidence? We have seen in the previous slide, IOU we will be able to compute IOU between predicted box and the ground truth box. For each of the given image, we would be associating, our model would be able to predict some bounding box. That is nothing but predicted box, okay? And as it is a supervised case, so it would also have some ground truth box, okay? So we will be computing the IOU between the predicted box and the ground truth box, and this would be 0 in case my predicted box is not overlapping, or it's not even in closer to the ground truth, right? So here, let us look at the network architecture of the YOLO model. Here it does have 24 number of convolutional layers and 2 fully connected layers. Apart from this, the 24 number of convolutional layers, using which it is able to extract the features, okay, from the given input image. Whereas from these 2 fully connected layers, the last layers which are placed after the convolutional and pooling layers, okay, these 2 fully connected layers are responsible to provide us the entire predictions in terms of those bounding box parameters, right? Now, in this, activation functions have been used with respect to activation layers, right? There are 2 different activation functions which have been used. For the final layer, linear activation function has been used, whereas for the rest of the hidden layers, leaky rectified linear activation function has been used. With respect to optimization, optimization is computed based on okay. One more thing, YOLO it considers, or it detects the object based on the regression. Okay, so it considers the problem as a regression problem. Hence, the optimization function which this particular algorithm has used is sum of squared error, right? So with respect to the model output, how it predicts. Okay, suppose as the input is divided into S cross S grids, and each grid produces B number of bounding box, let us say, and with respect to each bounding box, suppose here in our example, if we consider each grid produces 2 bounding box, then each of these bounding box would give us those 5 parameters, that is X, Y, W, H, and the confidence score, right? And here plus C. C here is the class probabilities. Suppose I want to detect the objects and how many classes are present in given training set of images. Suppose only 2 classes that exist. So in that case, what we can do, we can consider, okay. So what we can do is we can consider number of class probabilities. For some problems, we can have 2 number of class probabilities. For some other problems, there can be 10 number of classes that we want to detect our problem with, or we want to solve our problem with, right? So see, here is the class probabilities. So let us, at last, let us consider the how do we compute the intersection or union. Fine. Let's say this is the ground truth value. Okay, ground truth box. Fine. Here is the predicted box. Here, this one is predicted. Now we know if when we compute intersection over union, it would generate some result. There will not be any value which is equals to 0. Why so? Because there is some portion, okay, this particular portion we can say where my ground truth is my ground truth prediction or the ground truth box has an overlap with respect to my predicted box, right? So here is the common area, right? So this particular area is nothing but the intersection. Fine. So when we say that intersection over union would give us the maximum value whenever the predicted the predicted box is exactly overlaps over the ground ground truth box, right? So whenever it overlaps, we can say that intersection over union would be high, right? So here union is the entire region that we have considered of this particular ground truth as well as this particular predicted box, whereas the intersection is the area which has been overlapped with our ground truth and the predicted. So IOU here is A intersection over B. A is the area of my ground truth. B is the total area of my predicted. A intersection over B over A union of B. Correct? So union is the entire region of ground truth and the predicted one, whereas the intersection is just the common area, right? So now once we compute this particular value, okay, suppose we can keep this threshold. Suppose let's say the threshold value is greater than 0.5, then we do say that our product whatever IOU that it has generated, if the value is greater than 0.5, then we say that object is there in that particular predicted one, right? Predicted box. Okay, so with this, we will stop this session. Okay. So queries would have been handled by our TAs, right? So with this, we will stop our session.